Today, since it's close to Halloween, I've decided to get into the mood and talk about something extremely scary. Oh, I'm so clever. That is implicit differentiation. That's right. Implicit differentiation. So scary. So scary. So, we're just going to work through these problems. Let me see here. Draw. Where's my color? Something's wrong. There we go. Okay. Number 1 says x squared plus 2y squared is 25, and we want to find what says derive with respect to x. Y is not a constant. We really want dy dx. That's what we're looking for here. And anytime you derive y, you end up with the chain rule happening and getting dy dx. So for number 1, we're going to derive this bad boy and get 2x plus 4, because 2y squared is in there for y, times we derived y, so now that turns into dy dx equals 0. I'm doing a little bit of math and magic. Dy dx is negative 2x over 4y, which is negative x over 2y. There you go. Dy dx, negative x over 2y. And this is still the slope. Okay, so whatever this curve makes, looks like it's going to be a hyperbola. Not a hyperbola, I'm sorry, an ellipse. The slope of that ellipse is negative x over 2y at whatever points on that curve. Alright, let's keep going. Number 2. X to the 2/3 plus y to the 2/3 is 16. Deriving each side gives us 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3. And since we derived something with y in it, we're going to multiply it by dy dx because of the chain rule, and that equals 0. We're going to move over this 2/3 x to the negative 1/3 and then divide by 2/3 y to the negative 1/3. And we'll end up simplifying it later on. I'm not too worried about it right now. We're going to get negative 2/3 x to the negative 1/3 divided by 2/3 y to the negative 1/3. Yeah, now 2/3 are going to cancel, which leaves me with negative x to the negative 1/3 over y to the negative 1/3. And all the negative exponents do is if something's in the numerator and we've got a negative exponent, it moves to the bottom. And if something's in the denominator with a negative exponent, it moves to the top, the numerator. So really dy dx is going to equal negative y to the 1/3 over x to the 1/3. And if you really want, you can write that as negative cubed root of y over x. There you go. Keep going. Number 3. A little more complicated. We got the product rule happening here. Deriving both sides again is going to give us 6x squared plus, and because it's 3 times x times y, that's the product rule. 3 doesn't really matter. I'm just going to stick it with the x. So we'll look at this as 3x times y. So think of it like this: 3x times y. We're multiplying two things together, so we got to do the product rule. Product rule says derive the first thing, that's 3, times the second, plus derive the second thing times the first. So that's going to be dy dx, derivative of the second thing, times the first thing. That's the derivative. This part right here is the derivative of 3xy. Minus 8y, just by power rule, times dy dx, since there's a y being derived. And that is 0. Now, our goal is always in this case to solve for dy dx, so we move everything that does not have dy dx onto the other side, and everything that does have dy dx onto the left side. Since there's nothing on over here, it's just 0, we don't have to worry about that. So we're going to have 3x dy, 3x dy dx minus 8y dy dx is going to equal negative 6x squared minus 3y. Now we're going to factor out dy dx and divide by what's left. So essentially that's going to give us dy dx times 3x minus 8 equals negative 6x squared minus 3y. If you're thinking ahead, you can really skip a lot of this work. And now we're going to divide both sides by 3x minus 8. So we're going to divide this all by 3x minus 8 and divide this all by 3x minus 8. Over here, since we're multiplying, these guys just cancel out. And we'll be left with, I'll write it up here, dy dx is equal to negative 6x squared minus 3y over 3x minus 8. And you can't cancel anything out here. You can't cancel the x's because there's minuses on the bottom and top. It just doesn't work out nice. So that's your final answer. We'll box it off for you. There you go. Number 4, clear. Number 4 is a little bit nastier than the others. Lucky you. Now we got to do the chain rule and the product rule in here because now it's sine with something inside these parentheses. So there's an outside function with an inside part. Xy squared is inside of sine. So chain rule says we'll derive the outside part first. Outside part is sine. So that's going to turn into cosine. And the inside part stays the same. You do not touch it. Remember, you're peeling back layers here. Now we're going to multiply by the derivative of the inside. We've derived the outside. Sine turns into cosine when you derive it. Inside stay the same. Now we're going to multiply by the derivative of what's inside, and that's xy squared, and that requires the product rule. Again, it's x times y squared. Product rule says derive the first thing. I'll put this in brackets because we're multiplying it. So that's 1 times y squared plus 2y dy dx. That's the derivative of the second times x. So that's what chain rule says to do. A little bit nasty, but really not too bad. It's just a bunch of derivatives at once here. Square root of y turns into 1/2 y to the negative 1/2 dy dx. Now we got to simplify these things. Again, our goal is to get dy dx by itself. We've got dy dx here and dy dx here. We need to get them together on one side and then factor out. Problem is, on this left-hand side, we're multiplying all this junk by cosine xy squared. So, to make this simpler for ourselves, we're going to distribute that. And we're going to get y squared cosine xy squared, okay, from the first thing, plus 2yx. I'm going to put the dy dx at the end here. So cosine xy squared. We're multiplying, so I'm allowed to move everything around if I want. Dy dx. That's a 2y, and x was here, so I just put them up front. Cosine xy squared, and then dy dx. All that stuff's still there. Equals 1/2 y to the negative 1/2 dy dx. And you can take care of that negative exponent now or at the end. It really doesn't matter. But I'm going to get all my dy dx's on the one side and everything that doesn't have dy dx onto the other. So I'm going to leave 2yx cosine xy squared over dy dx on the left side. Okay, I'm going to subtract off this whole fraction, product, whatever, minus 1/2 y to the negative 1/2 dy dx. And that's going to be, I'm moving this part here over to the other side because it does not have a dy dx. Y squared cosine xy squared. Okay. Now, what do we got going on here? I'm going to slide all the way down the bottom. Okay. We got more room, so we'll keep going down. Now we need to get dy dx by itself. So we're going to factor out this dy dx. And what's going to be left inside of here is 2yx cosine xy squared minus 1/2. Ah, man, don't do that. Where's my eraser? Sorry about that. What is going on? You are a total piece of junk. What just happened here? There we go. My God. So, this is what we got going on here. This is a minus. And this equals the same thing that's on the side. Y squared cosine xy squared. Very professional for me to be yelling at my computer like this. Anyway, we've got, we need to divide by all this mess here. So we're going to end up with dy dx is equal to Over here, y squared cosine xy squared. All that is over just this whole big fraction. 2yx cosine xy squared minus 1/2 y to the negative 1/2. And technically, we don't want to leave this negative 1/2 here. So we're going to multiply, just because we don't want negative exponents. If your teacher doesn't care, I guess I really don't care, but since I'm probably your teacher, I care. We're going to multiply by y to the positive 1/2. And that's going to kill y to the negative 1/2 when we multiply by it. So up top, we're just going to get y squared times y to the 1/2 is y to the 5/2, because you add the exponents. Cosine xy squared over, and on the bottom we got to multiply y to the 1/2 times the first large product. So we have y in here times y to the 1/2. That's going to become y to the 3/2 x cosine xy squared, and then y to the 1/2 times this is going to become just 1/2. And if you don't want the 1/2 there, you could, instead of multiplying just by y to the 1/2, you can multiply by 2 y to the 1/2. And what that's going to do is we'd have a 2 here. This would be a 4 instead of a 2. And then this 1/2 would just be a 1. Okay, that looks super sloppy, but again, it really just depends on if you want to get rid of that fraction or not. So, nothing too bad.